If I ask you the question, what do you think karting is more like? Is it more like an art or is it more like a science? Well, if you asked me that question a few years ago, I would have told you, well, it's totally an art. It's so much based on experience rather than science, as it could be Formula One. Formula One may be a mini NASA space project, with all the technology, with all the engineers, etc. But if you ask me today, again, the same question. So whether I thought karting was more of art than science, I will tell you it's more of a science. And despite people treating it still as an art, I believe that the world has changed. And as the world has changed in many scenarios and many different sports, as it has been in Formula One, it has changed in karting too. And you can't still consider yourself to be on top of your game if you are just treating karting as an art. Let me explain. So even though there still is there still are many factors that are very difficult to track and measure in karting compared to Formula One or any kind of single seater. For example, in karting, it's difficult to tell exactly the cart balance, and it's a bit difficult to tell exactly. I mean, the flex of the chassis. You can't tell the flex of the tube. There's no sensor that can really tell you when the car is driving, what sort of behavior the frame is having. You can have many different sensors on the tire temperatures, on the tire pressures, on exhaust temperature, RPMs, lateral and longitudinal G-force. You can have like water temperature, etc., engine head temperature. There can be quite a few sensors you can add, but you will never have the exact certainty of what the kart is doing because you don't have all the tool at your disposal, as in the case of Formula One or as I said, in other cars. For example, in single seaters, GTs, Formula One, you have so many parameters, and you have also got so many engineers that are able to analyze all that data. You got ride height, you got dampers, all sorts of suspension data, and the aerodynamics. Also, I've got many different parameters to follow: the front, and the rear, and the floor. So there's many things that a engineer has to look after in cars to optimize performance. That's why there's so many engineers. That's why the costs have gone up so much in the last few years, because the competition has gone up. Teams like Prema, they've got so many engineers already in F4, and so obviously that drives up the costs, but at the same time that drives up the competition massively, because think about it, a team is able to monitor absolutely everything of a specific car from a specific driver, as I said, from tire temperatures to tire pressures to lambda values to gear ratios, like obviously talking about cars, suspension setting, aerodynamic setting, ride heights, etc. Compared to a smaller team that perhaps is only able to work on the few minor aspects, such as like gear ratios, ride heights, driver inputs, so like throttle, brake, steering, etc. That team will have a much bigger chance of outperforming the smaller team given the same driver. Obviously, the driver still makes a difference in karting, whereas in cars, I believe it's more the car makes a difference. Obviously, at some point you will have a team of 2, 3, 4 drivers, and the driver that's like the bad driver will still outperform the worst driver. So the best teammate will still come out. It will still, shine. So you will still be able to see the driver in cars too, but like from team to team, it's gonna be very difficult, because you're gonna find some teams that are gonna be very well funded, that have very good knowledge, very good research, and they're gonna provide better performance from the car. In karting, it's happening the same. And being a team manager together with my brother at BabyRace, we are facing this reality that we have to keep improving ourselves. We have to keep getting better from that engineering side, even though again we are not a single seater team, but we have to start to be more and more like that, because we already have now got like 4 data guys, including myself. I do team managing, and also I work a lot with the drivers, with the data, with the videos, and also from the performance side, taking care of tire pressures, tire temperatures, carburation, etc. So I've got a few roles, trying to obviously work on the driver side, but also on the performance side. And I really want to do all those things, even though obviously at the end of the day, quite, I'll be quite tired. But yeah, I mean, I feel that with my experience, I am able to bring to bring some insights into that side. But I don't want to digress. Going back to the main topic of the video is that, yeah, karting is becoming more and more a science than an art. So you'll have to chase parameters. You'll have to get your car to be in the window, in the optimal operating window, as I call it. It's the performance G spot. Think about it. You got the engines, well, the engine. You got the carburetor. You got the radiator for juniors and seniors. Then you've got, also for shifters, you got the tires. You got the rims, and obviously you got many other accessories on the cars. But the main ones, let's call them, are the tires, the engine, the radiator, and the carburetor. Let's say, and also the brakes. They're very important too. And don't expect these accessories. Let's call them accessories because, okay, your brakes are accessories, even though the tires are accessories too. But yeah, they're components, they're parameters, they're the components of your go-kart. So if you wish to have performance nowadays, you gotta be scientifically looking at each of these parameters at a singular individual level and try to figure out how to optimize the performance of each of this tool, each of this parameter. And so you have to think of this. You have to think at your engine as a number. It could be the average horsepower. That could be a number. So most drivers have a number one race engine and number two test engine, which normally is like 1/2 difference. Obviously, depending from category to category, but that's quite the case. Then there's carburetors. You need to have a number attached to a carburetor. There could be you could be you could put like 20 carburetors on the dyno with exactly the same settings, but you'll find that a few of them will outperform, and so you will need to know the exact average horsepower of each carburetor. So that's going to have a number. In terms of That's in terms of performance. So engine and carburetor side, there you have a number. So that's going to be okay. There's a scientific approach. I just, you know, I need to know that everyone has a number one race engine and everyone has to be a number two race engine from a team perspective. The driver doesn't know it. Like, the driver is not supposed to go and ask the team, hey, what's exact number of horsepower this engine has, and what's exact number of this carburetor, like what's exact horsepower they have combined. You can't quite ask this question, but from a team perspective, you need to know. Then that's basics, but then you have to go in and have a look at the average temperature of your tires. You have to look at the tires singularly. So each tire has to have specific tire pressure, specific tire temperature. But then you also have to look at the average of the four, just to know which ones are the colder ones and which one are the water ones. But you definitely want to have an idea on the average side, whether you're too low on tire pressures or too high on tire pressures, whether you're in too low temperatures or too high on tire temperatures. So you want to have an idea at any given time of your performance. Obviously, the tires are the only piece of your kart that is in contact with the ground. Therefore, the tires will always give you an idea of what's going on in your kart. So if the tires are not going up to temperatures, it means you're not working the tires hard enough. Therefore, it could be driving related, which I believe is 90% of the case. And that 10% of the case, the driver may still push like hell on the tires to get them to warm up, but they may be too soft in the setup, like so many different things that could not allow the tires to heat up. Could be like on magnesium rims, stuff like that, and maybe in the deep winter may not work. So there's a bunch of things that affect the tires in this case. I don't want to have a specific look on tires in this video. There's more videos related to that. But the point being is that each of the components of your kart has a number. As I said, from the performance side, the engine has an average horsepower number, and the carburetor is an average horsepower number. Ideally, your race engine has got really not high number compared to other people on the grid. But again, we are not just talking about setup performance as engine tuning performance. We are talking about absolutely everything. So it's not just the performance of the engine or the performance of the carburetors. There's also a lot to deal about the temperatures. So temperatures are not everything, but are a big portion of the performance of your go-kart. As I already discussed, tire temperatures and tire pressures are related to those, but they're a little bit different. As I discovered through the years, is that tire pressures are not as important as tire temperatures. They are a bit of a tool for tweaking the tire temperatures, because at the end of the day, what defines friction, defines the actual grip you have in the track is the temperature of the tire. You may have, let's say the target tire temperature is 0.85 bar, but it's winter and you may already set the tires at 0.85, all right? And despite that, like cold 0.85, you're like, okay, lap 1 should be my best lap because I'm already at the target pressure. But it doesn't work quite like that, because the reality is that what defines, as I said, the grip, the friction, is the temperature. So you may still get the best lap on the last lap, even if you start really high in the tire temperatures, because, as I said, what really determines grip is the tire temperature. And as you will see with very hard tires like Comets, MGs, I haven't really worked with Maxes because, obviously working with me only. But yeah, I know that Maxes are quite hard too. So they may struggle with generating temperature, and therefore, in the first few laps, you will always be struggling with grip. But yeah, temperatures is very important to keep track of. And if you don't keep track of, you will never know whether your setup is good enough, because you may have a very good balance of the kart. The front and rear could be very balanced, but maybe you have too much grip and the temperatures are reflecting that. Or maybe you have too little grip and you're sliding around on 4 wheels. The temperatures may be reflecting that. Normally, if you are too low on tire temperatures, you will be sliding on 4 wheels, as you probably have noticed yourself. Then when the tires come to the right temperature, you may be balanced. But then if you have overheating due to, for whatever reason, like driving style related, chassis related, could be that the setup is too stiff and just overworking the tire, then you will start to slide again if there's overheating. So basically you're sliding at any time, whether you're below the tire temperature severely. Let's say the target is 80 degrees Celsius and you're like 50 degrees, you're going to be sliding until you get to the point. But then if you cross the point, you go to like 100 degrees, then you're going to slide again. So you're going to slide if you're too low, slide if you're too high. In one case, you're going to get graining if you're too low in temperatures. In one other case, you're going to have blistering, because you're going to see the tires like kind of melting away, which is happening a lot in downlaps in KZs, I heard. And but yeah, just that's going to be another thing. You want to get your tires to be in the optimal operating window. You're gonna want to have those half tires in the zone. Could be 80 degrees, could be 85. It really depends. Like sometimes the manufacturers are gonna give you the range that you should be aspiring to, but what I've noticed is that they're not always quite correct. And I know it sounds arrogant to be trying to prove wrong the tire manufacturer, but sometimes it's not like that. Sometimes they may give you some unrealistic tire temperature goal or like unrealistic tire pressure goal, and when you try them on track, they may not look as good as a completely different. Maybe they're not completely different, but like a slightly different, like a little bit less or a little bit lower. But what I noticed through the years is that the tires are getting like less and less grippy, more and more ecological, and therefore it becomes more and more difficult to generate the temperature, because the softer the tire, listen, the harder the tire, the more temperature it needs to be working out the optimal window, like to have the optimal grip. So they're typically better in the summer months when the track temperature is like 50 degrees, 6 degrees here in Italy. But they're very bad when the track is cold, when it's like 20 degrees, 15 degrees. So in that case, it's better to have softer tires, but you can't really change. Like you can't really like, okay, I go to WSK and I'm gonna opt for for options, or I'm gonna opt for primes. I'm not gonna opt for the soft ones or the hard ones. So you just get whatever they give you for the series running. So you just have to know that softer tires, as they've been in the recent years, the Vega, even though Vega is starting to also start to be quite hard, as I said, for the ecological reasons. As I said, they are, the softer tires are typically able to work, like have a higher grip in lower tire temperatures, but they struggle in the summer with overheating. So you may get the peak performance on lap 1, 2, and then it goes off because it gets too hot. And again, you may start to slide quite a bit. So as I said, that's from the tire side. The pressures is also something very important, but I think is not as important as the tire temperatures. The tire temperatures is the key. But then you also have other things that you have to take care of, and these are brakes. The brake temperature is very important. If you can't get your brake disc to work at the correct temperature, let's say it's very cold, it's like 0 degrees or -5 degrees, and there's a long straights, and let's say you have really hard and worn pads. In that case, if you're not able to have the optimal temperature in this, you're basically gonna go at the breaking point and not have the perfect bite, because the temperature is not there. You will not have the optimum bite, and therefore you will not have the optimal stopping power as you would have in the optimal condition. So in that case, you'll have to brake earlier, which is not ideal for many reasons. One being that you can't overtake. The second being, for a lap time, you have to brake late and hard. And third is that normally when you can't brake late and hard, you cannot generate temperature on the tires, which affects massively the grip through the rest of the corner, through the rest of the lap. So that's very important to take care, to pay attention. And the opposite scenario is that, okay, let's say it's too warm. It's too warm, like it's like 35 degrees ambient temperature and like 6 degrees track temperatures. Celsius, obviously. In that case, you may have overheating on the brakes. So you may have lap 1, lap 2, and then like you start to feel the brakes are spongy because the oil overheats, the disc overheats, the oil over. I don't want to get, I'm not too technical. I don't want to get too much in depth. But yeah, when the brakes are overheating, that's also not good. So you see so many drivers, so many teams putting diffusers towards the brake system, which we do in the summer months, to keep the brakes a little bit cooler. And it's not just for the braking purposes, like low in mini, for example, and also in juniors, but in mini, that's the most, I would say, affected. If the brakes are not working properly in the overheating, like the O-rings inside the brake calipers and the pistons, they're basically not gonna be working as well, and they may start to slightly inflate, and they're not gonna allow the brakes to come back properly, like the brake pads to come properly off on the exits after you have released the brakes. So you release the brakes, you expect the brake pads to come off the disc, but sometimes when the brakes overheat, the pads are gonna still rubbing on the disc on the exits, which is really bad if you consider that 60 minis have only 12 horsepower, and if they are rubbing the brakes on the exit, they're losing so much power, and also you're overheating the engine too, because it's like if you're having a handbrake through the rest of the lap. So it's something we have to really take care of. So that's a number. What's your average brake temperature? And then there's another number which is very important, and that's the carburation. So it's related to the exhaust temperature. So if you have really high EGTs, the top, you may be too lean. If you have very low EGTs, you'll probably be too rich, which means but essentially that you have more fuel than air going through your engine, and therefore the combustion is not proper. I use the lambda values mostly in this case because I believe they are the most accurate. They're more accurate than the exhaust EGT temperatures sensor. But obviously they are way more expensive. Like the kit from AIM is like 700 euros, which is quite expensive. But yeah, it's very, 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 very reliable. So yeah, but what you should do, I mean, if you don't have a lambda, you should just check the exhaust temperature and have a look at the minimum and the maximum. And you want to basically understand the carburation in the bottom and the top. Normally, a range could be like 440 to 450 in the bottom, or 620 to 630 in the top. It really depends from like the sensor you use, in the category you're in, the engine manufacturer. Like the engine tuner normally has to tell you what's the sweet spot, what's the window, the optimal operating window. And if you obviously have a membrane carburetor, you can tune the carburation yourself, either on the pit lane or while you're driving, which I used to do, and I actually really enjoyed doing that. And another very important aspect is the engine head temp. Like the water temperature is key, guys. As I said, except me's and like categories that don't have a radiator, the water temperature is very, very important. I probably shouldn't even mention, like, it's kind of obvious, because basically the radiator temperature is not just for the sake of the radiator. Who gives a crap of the radiator? It's because it's connected to the engine head and everything. So if you're like forgetting uh, the the radiator curtain up, you're basically going to arrive at almost like 100 degrees, and the engine is going to be the cylinder may start to actually not kind of melt, but yeah, I don't know exact, but for sure you're gonna be risking to seize the engine, or like damaging the engine severely. So yeah, in that case, regulating the temperature is very important. In the summer, in the winter, you don't want to be too cold, like below 35, 40 degrees. You're gonna risk seizing the engine there too. Or if you're too hot in the summer months, you're gonna risk, as I said, first of all, losing performance, because once the engine goes up to like 55 degrees, you start losing bottom like a lot. The top doesn't get affected as much, but the bottom is highly affected. So engine temperature is very important. It's related to the radiator. So also looking at the engine head temperatures, especially for mini cars, that's quite effective. But yeah, so as I said, people used to treat karting as an art, but I believe nowadays it's becoming more of a science. And if you are able to put together all those numbers, like when I look at the card, I'm like, okay, there's all little, like it's like if I have some numbers coming up on the card, and I'm like, okay, and my goal would be to have all the temperatures, all the numbers in check, but it's not always quite the case, you know. It's not easy to have that kind of monitoring on all the cards, but that's what something I'm aspiring to, because the more you're able to keep everything in control, because maybe, like, listen, if you want to have optimum performance from the card, you need to have everything to be in the window, in the optimal, as I said, performance G spot. If everything is perfect, but your tire temperatures are too cold, you're not going to have the performance. You're going to be sliding around everywhere. If everything is perfect, the tire temperatures are perfect, but then your water temperature is 80 degrees, 90 degrees, you can everything else be perfect, but then that just one little thing is going to destroy performance, or even not even allow you to finish the race. If everything is perfect, tire temperatures, water temperature, exhaust, like, but then you realize your brakes are overheating from lap 2, well, then you're probably gonna not be able to brake as late, as hard, and make the overtakes as efficiently as you would normally do. Let's say the brakes are perfect, but then everything else is perfect, but then you realize your exhaust temperature on top is very, very rich, so it's very low. Therefore, there's too much fuel going through the engine, not enough air. So either you figure out a way to get more air in the engine, or you just have to close the main. Either you change the main jet if it's for minis, like, or for membrane carburetors, you're gonna change the top, and you're gonna close, giving less fuel, and therefore, bam, ready to go. But if one of these aspects is not in the optimal window, then there's no way you can compete at the top in WSK, CIK races, RGMMC Champions of the Future. The bar has severely increased over the years, and obviously, if you're racing internationally, this is something you have to take care of. So think as your kart as a mini Formula One machine that has so many different components that have to be working in the optimal operating window, and you'll see that by doing so, you'll find more performance, and you'll have performance more consistently. It's not going to be random. When you have the performance, you know why you have it. It's not going to be, oh, I have performance, don't know how I have it, but you understand what I'm talking about. You're gonna take the right decisions, you're gonna be able to problem solve faster, and everything else will be better. So let me know if you got any questions. I'll be happy to respond, and I'll see you next one.